This is an early 50s Motorola Car Radio, and I just found it recently at a swap meet. Thought it looked kind of cool, and based on what I can find about it, it's kind of a universal car radio. It's got the speaker built right into the bottom, designed to mount under the dash, sort of a thing, and it is 6 volt. So I thought it would just look neat on my desk, but I kind of figured maybe we can actually get it to do something here. So I'm going to try to power this up and see what happens with it. I don't know if it's... All I know is it's 6 volt. I don't know if that's positive or negative ground, but if this is like a, well, early 50s, it's going to be like a tube with a vibrator power supply. So I mean, it does, the polarity really doesn't matter because these radios are running either polarity. So just kind of plug it in and see what happens. I've got power supply up here. This thing is not regulated, so which is kind of annoying, but at least I think it's wound all the way up. But I set it about there and put a load on it. That thing probably pulls a few amps at least, maybe. I don't know, but this thing will definitely drop down. But let's see what happens. Barely long enough. All right. Zip this in there like that. Maybe we'll get lucky. So either there's a short circuit or the thing's just drawing way too much power. Let's see. This meter isn't exactly accurate, and that's about 6 volts right there. This thing is not making any noise at all. It's probably about to go up in smoke. Yeah. So I don't hear the vibrator, nothing. No dial lamp. Oh, this is easy with one hand here. We could do this all day. This is probably the component side. Like I said, easy. Okay. Okay, better. Wow, so this is one of those, it looks like they kind of just did the bare minimum possible to make it receive stations. I mean, looks like it's got only 2 IF stages. And what else? Not a whole lot. On Here's the original. Oh, that said Stromberg. It is Motorola. Oh yeah, look at that. That's like the cleanest radio chassis in the world. Motorola tubes. It appears to be entirely untouched. So, see if these tubes light up at all. All right. Get a nice tight ground connection. And all right. Well, that thing arced a little bit and the power's turned off, so what is that? Is that this spark plate bypass cap? Probably. Oh yeah. Seems a little bright. For 6 volts anyway. Try something else. Get a little bit hot. Okay, let's see what our feed voltage is. Oh, there's our dial lamp. Okay, so it looks like it's just the high voltage supply that's not working, because this thing is not humming. Where's a good ground here? Ooh. 9 volts and it's still not kicking in that vibrator. The thing must be shot. Let's bring this down to her. Yeah, good enough. Good enough. So, I suspect this first thing. Buffer capacitors usually go bad on those and arc the shit out of the contacts and then they fuse together, but usually when that happens, I was gonna say it'll pop a fuse, but you can see what our fuse situation is here. Non-existent. I've got a couple of, oh, there's a 6 volt vibe right there. I can get this on with one hand. Nope, impossible. Okay. Oh, original Motorola part. Look at that. Imagine that. Used to have this snazzy test adapter for my tube tester that would check these, but no longer. So let's have to try it by substitution. Assuming this is any good. I think it is. What is this? This out of here. All right. Okay. Nothing. So I guess if you're not really familiar with what the vibrator is, it's basically an old-timey DC to AC chopper. If you think of a modern transistor power supply, taking a DC current and switching it back and forth, this is basically that. It's got a couple of reeds in it and a magnetic coil, and once it gets started, you apply power. It basically switches one of the poles of the incoming DC current back and forth, and it alternates the polarity of the DC, basically making the form of like square wave AC into that step-up transformer, which is part of what makes the high voltage supply in this work. Like any switch contact, these things can get pitted and they just don't work. Now, I thought this thing worked, so there may be other problems with this radio, but flip this thing over and see what's happening. Okay, now I got power applied to this, and there's the vibrator socket. This thing, boy, look at these resistors on here. A little corrody doodle. Okay, we've got our 6 volts there. And all right. Yeah. So, what is going on here? I've got the 6 volts here, which is the output right into the transformer. So right now there's just 6 volts DC sitting flat on that thing. That's not good. Maybe not. Maybe I was looking at the wrong lead. So you've got... Okay. Alright, so I've got 6 volts on all 3 of these pins. This one should be ground. Yes, it is. Sometimes these things are so oxidized, they're hard to get a good read on. Okay. So this is a 6 volt feed. This is basically just an input choke. Just a coil of wire inside a little cardboard case there. It is feeding off of that, so there's our, well, it says 8 volts, but you know, it's a little bit high. So it does kind of look like this vibrator might be bad. See what I can do about that. Okay, so it was the vibrator. I pulled one out of a known working radio and popped it in there. Oop. And there you go. Thing is making noise. See if we get anything at all out of this. Doesn't sound like it. Got B+. And how? Oh, I thought I heard a little noise from the speaker there. Come on. Okay, what? There it is. Alright. This is the cathode bypass for the output tube. Alright. This is going to have to be replaced. This is that buffer capacitor I mentioned. I don't care. Anytime you replace well, in the old days, the service literature said that anytime you replace a vibrator, you have to replace the buffer capacitor. And obviously, this is well past its lifespan. It should be replaced. It's probably arcing the shit out of the points in that vibrator I put in. So, and that's okay. Let's plug the antenna in and see what happens. I'll be damned. Okay, that's turned all the way up. I don't know if it's coming through, but there is something happening there. Not that AM reception where I'm at is all that great anyway, but should be able to get something. The volume turned all the way up. I mean, you should have rushing static. I mean, this is not either the AVC's having problems or something. Weak tube. All right. Make sure to get a few sparks here. Look at this. That is 100% serviceable. Okay. Tube sockets seem okay. So I guarantee, well, we got good B+, so the rectifier tube's okay at 6x4. I can hear something. Unfortunately, I don't have a schematic to be able to check the voltages on any of this stuff. Let's see if I can find those, find that station. Where was that? Oh, it's fine. It's just nowhere. Probably ought to check these tubes next. Already I found one of these IF tubes, the 6BA6s, instantly. Short, grid emission, and it checks almost way too good. So it's probably got air in it or something. It's typical of a gassy tube. You have all three of those things. So I'll put another 6BA6 in it, but let's see what the other tubes check at. See another 6BA6 from the first IF. Shouldn't really test that good. 78. Yeah. Okay. Yeah. I guess that's all right. But I'm not used to tubes checking quite that good, so I'll give that one an okay. Let's plump that one back in there. Is that a 6BE6? Right there. Come on. Yeah, that one is not having it, is it? Even with weak emission, with no short, grid emission, that's probably going to function okay, but it should be replaced. So the first tube in the series, what is that, a RF amp? Well, I looked around and I've got some 6BA6s sitting around in a box. There's one of them. The 6BE6 I don't have. I've got a parts radio here. And there should be one in here. Here's another. Yeah, it's probably it. Usually on these, 6BA6, BE6, BA6, and then AV6. So is that the BE? Yes, it is. Let's give it a test. What is going on? Are these tubes really bad? It seems like it started there it's ready to go, and then, oh yeah, it's definitely no good. Sags like that, it's usually the cathode's used up on it, or it's got gas in it. Yeah, definitely. I think it's got gas in it. Well, I have to find another one. Okay, well this tube's back in. I didn't have a replacement for that one. That's the 6BE6. I'd probably do somewhere, but I'll have to take apart some other radio to get one. Now, I'm kind of thinking, since this radio only has 2 IF stages, that we've got a converter tube. We have the first IF, which is that 6BE6, the second IF, and then the, wait a minute, no, mixer oscillator. I don't know, I forget. But detector, second IF, first IF, converter, I think. Yeah, anyway, let's see what this thing does now. A little more volume. Should be my little AM transmitter right here. I can get a station. I don't think I can get any AM stations back here in this shop. Yeah, there's definitely more volume. Signal strength is lacking, but that's pretty much across the band. It sounds like, well, oh, that's weird. The volume control's now acting like a tone control. I've got to have a leaking capacitor here or something. This radio doesn't even have a tone control on it. Okay, how interesting. So, still got some problems. Being that this thing has this 3/4 inch form factor IF transformers in it, I don't know how far I would want to take the repair on this radio. This is primarily just I don't know, just something for looks. But because this has those capacitors integrated into the bottom of them, and they suffer from silver mica disease, and it's a process to get in there and do those. So, yeah, I don't know. If I make any more progress on this radio, then I'll go ahead and document it. But that's it for now.